It's called Automatic Counter Module for Bed Boxes. I will start explaining the how and when and why of this project. And Thijs will talk about first results of the measurements we took and the future developments we are aiming for. The project started, the idea started when I met Thijs at a small conference of a regional group of bed workers, where he had a presentation on a bed counter placed on a serotine summer roost in the back garden of his parents' house. It's a nice study object to have in your back garden. Well, I was having a presentation about a successful mitigation project enforced in the Netherlands, where we were able to persuade a maternity roost of 200 pipistrelles to go and live in a box. Together, that led to the idea of a bed counter on a large maternity bed box. And why? The background is that I work as an environmental, what do you call it? I give advice on development projects, and very often demolition of buildings in such projects cause problems with bed roosts. In the Dutch legislation, you have to have a permit to destroy, take away a bed roost. It's a bit too hot to go into details of those Dutch rules. But anyway, in order to give you a permit, they had to have redefine the word destroy. And destroying is not destroying if you take measures that will allow the local group to function in any time and space. And that means that even between in the period between the demolition and the new build, you have to take measures to compensate the loss of a roost. The Dutch government also has a booklet with rules of thumb, how to successfully perform mitigation. One of those rules is that you need temporary compensation, and that's normally done with bed boxes, and you have to give the beds some kind of period to get used to the new roost, or at least have the chance to discover the new roosts. And for a summer roost, normally a period of 4 months is said to be enough. For summer roosts, at least 1 season is said to be enough. But if you asked beds, is 1 year enough to successfully use a new roost? They probably say, well, we've seen quite a few presentations where there's hardly any success with bed boxes, at least not in the first year. And I think maybe the beds will say, well, nobody told us to move, so why would we move into a new bed box? On the other hand, if you ask the developer, probably you say, well, 1 year is 1 year too long. I already had to wait 1 year to get all kinds of investigations to see what the problem is, and now I have to wait another year before I can start. Normally there is no monitoring of those temporary measures. There's no time, there's no money. And the bed counter on the serotine summer roost gave me an idea of a technical solution, an electronic monitoring, and that way that it would report the very first use of a bed box. Some kind of a bed phone, so it would phone and say, hey, I found this place, you can start with demolishing my other roost. that was the idea. But of course, there's more to come. Well, we found a place to experiment. The municipality of Ede in the Netherlands were kind enough to host a bed box, which is adapted, and the location is somewhere in the middle of the Netherlands, on the northern edge of the city of Ede, and further to the north, this is the north, is wooded areas, and this area is also a bed reserve for pond bats which have roost in the trees, but it's known that in the near vicinity is a roost of serotine bats, and also some small roosts of pipistrelles. It's also very near a location where a school was demolished, which contained summer roosts of pipistrelle bats. Well, the bed box we adapted is a what we call a normal, sorry Erik, kostenkast, based on the American design, but a bit smaller. This is half the size of the bed box we used in Forst and the bed box Erik used in Tilburg. The reason is that the very big one is very hard to handle, and probably half would be enough. We used that one to adapt and to suit for all kinds of electronics. Of course, a sluice with light sensors to monitor whether bats are going inside or going outside. But while building, of course, you want to know much more about the circumstances in the box. So we also fitted it with all kinds of other sensors, mainly temperature sensors, but also humidity, barometric pressure, and a light. So there's a little, you can see it on pictures, a sensor for the lux. The installation, a few pictures, starts hanging a big a box, starts with a single plank, small plank, with a 40 to 45 degree angle, so you can hang the whole box on the wall, and then it's with a few screws you can attach it. We thank the gemeente Ede for this. In our new building, they drilled a hole where we could use electricity and internet connection, because we want immediate contact with the bed box, and we want to be able to read our data. Well, we put it on, then you have a lot of wires, electronics, which have to be fitted, which was not easy. But at the end of the day, Thijs was very satisfied with the result, and all the wires are very neatly tucked away, and so that they are all in this compartment, and the rest is all for the bats. First results.
Okay. Yeah. I'm gonna go a bit back to the location in my parents' backyard that Edwin talked about. My father is an enthusiast, and he has made what you could call a bed box, a single-chambered bed box on the top side of this wall. It's actually occupied by pipistrelles and serotines. This year, at most 7 individuals, so it's not like a large roost or whatever, but I used it just to test the first setup of this device. A single light barrier, no sensors, and just to see what would happen. This is what happened. In about 2 weeks and a couple of periods of some days, we collected 445 records of activity of bats. So this could just be like a bat peeking its nose, just interrupting this light beam. That would be a record. It would be an interruption of this light beam. So this is just a visualization of all this kind of thing. It could also be a bat emerging. It could also be a bat just sitting at the entrance, like puffing because it's too hot inside. It could be anything. On the x-axis of this graph, you see the time of day. So it's midnight at the left side and midnight again at the right side. And on the y-axis, that's logarithmic. So it's 1 millisecond of interruption at the bottom, and on the top it's more than 10 hours of interruption. So at first I was surprised actually about the more than I believe the maximum was 13 and a half hours or something. I was surprised, and then my father said, no, well, it can actually be in this period of time, like in this time of the year, in August or September, it's so hot that they actually are sitting during the whole day at the bottom of this small bat box. So I was quite happy with this and decided to continue. This is the bat box that we've put up in Ada again, so that's exactly the same thing as here, apart from the luminance sensor. That's I don't believe you can see this, but it's just like here is a ventilation opening, and here is a sensor of like 40 mils diameter. So Anijevke, I don't know where you are, but you asked for a sensor of luminance. Here it is. Apart from that, there's also sensors of barometric pressure, and there's 4 temperature sensors. And the temperature sensors, there are 2 in the top part, and they are located like in the front and in the back. And there's 2 at the bottom, and they are located left and right. So we have a pretty good idea about like the temperature gradient throughout the bat box. It's actually facing east. It's on this side of this is north. It's on this side of the building, and hard to reach actually because here is a bit of water. So putting up a ladder against the wall was already an achievement. So I'm just gonna show you a couple of graphs. This is by no means analysis. This is just visualization of the data that we have. As you can see, the data runs to the 8th of October. We haven't had time since then to analyze anything. What you can see from this is that the gradient, and this is in the end of March, that the gradient in temperature each day is about 20 to even 25 degrees. No, here it's 20 degrees from like on the coldest point in the night to the hottest point in the day. So we believe that we should look at like a buffering of this bat box. We believe it's too high a variance. And actually, I've put in the minimum and maximum temperatures throughout this period, and you can see that it goes up to over 50 degrees Celsius. So that's also it's just too hot. This is what is it? Illuminance. Yeah, it goes down to 0 nicely each night, obviously, and apart from that, you can just see, like during the day, if it's a cloudy day or not, if there's and over the time of a year, like how long the day is. So that is just that gets nicely visualized. But apart from just knowing how long the day is, you also have the effect of clouds or whatever, rain. So I'm going through this quite quickly because it's just data. We didn't do much with it. This is barometric pressure, also over the course of the same days. So you see that the fluctuations in temperature and illuminance and now in barometric pressure are very different from each other. So that's nice to see, at least. It's as expected, obviously, but yeah, still nice. This is humidity. We are a bit lower than Ireland, luckily, I would say. But this is an interesting one, I think. It's does any one of you know the spaghetti monster? This is it. Now, on the x-axis you see temperature, and on the y-axis you see barometric pressure, and there's not much relation between them. But that's also not what we're looking for. We're looking for a sort of a visualization of the niche of bats in a bat box. Like, what is a bat looking for in a bat box? And as we don't have any bats in a bat box yet, we can't look at it. But it would be very nice to have within the range of temperatures and pressures and humidity that can be in a bat box, to see which part of that range is still interesting for bats. So to visualize, like with two different colors or whatever, like I showed you in a 3D graph on the top, to have a sort of a suitability index for bats, and to see when do bats use boxes, and how can we adapt boxes to meet those needs. So we're following several lines of development with this. It would be very nice for hibernacular to have a light curtain, as is shown here, to not only be able to, like this would be here, just to explain, and there's several compartments, but they all have to enter and emerge through this one slide that's about 80 mils wide. So it's only one area, one place where you can enter. With an hibernaculum, in most cases you have a much wider area, so it would be nice to have a light curtain to also be able to sample those sites. Also, we'd like to put the data that we collect online and visualize those, and also make it possible for people to make their own visualizations. Our studio and the Shiny package can do this. And in this case, we would have a network of several of these boxes with sensors that send their data to a database, and that then on a website could be visualized. It could look like something like this. I don't know how many of you know this, but it's a very nice project, as far as I'm concerned, in Denmark, at the Mønsted Kalkgrube. It's like a limestone cave, a limestone mine. They have put up similar devices, and at the website on the top right, you can find this and actually change it. So you can change the period on which it aggregates the data. You can say which period you want to see. It also visualizes temperature, and so yeah, I really think it's a nice project of theirs. So I'd like to have something similar like this. Other things, we'd like to open source the whole system, so software, hardware design, data, everything should be open source. And for the design part, we like to have a repository on which we can put all the design files. Species recognition obviously would be a very nice idea. So to have photographs of bats emerging, or sound recordings, whatever. I can imagine several things, but this would be a nice addition. To have tags, transponders, RFID tags, to have a readout of those, that would be nice in case you have a project with that. It's just an easy addition, actually. And what is a very nice idea, as far as I'm concerned, is to have a mobile system that is solar powered and connects to the internet by a telephone and not by a cable. And it could look like this, to have a bat box with a module that you can add onto it with just 2 bolts, in which the electronics are all placed. Bats enter through this module, and via this route come into get into the bat house. But as they have to enter through this, you can count them there. And if you are done sampling and you want to sample another box, you can just put it, get it off and put it on another box. And as long as a consultancy or a, you know, as a wildlife reserve or whatever, you have all kinds of boxes that are the same. Like we use this box and use it over and over again. You can just make one thing that fits that box and move it around as pleased. So that would be very nice to have something like this. Yeah, so this is it. Thank you.
Thank you very much. Are there any questions in the room? Yasha?
You started with your presentation with a problem of bats hanging out of the entrance so that they block the counting, I guess. Were you able to solve that, or is that still ongoing?
Well, yeah, you could call it a problem. I actually didn't, but well, the problem in that is that as long as a bat is just sitting there, no other bats can be detected. So that's the problem in that. You're right. And it would be solved by just comparting the entrance and having, so you would at least limit the problem. If one bat limits one compartment, you'd always have the other compartments to count bats there. But yeah, that will remain an issue, I guess. I know Karel Kugelschafter, they made a system in which bats had to fly through a gate in which they couldn't sit on, but I forgot the specific setup. So there is possibilities there, but yeah, it's not easy for a bat box. I don't know of a solution, no.
Any other questions?